Okay, so to calculate empirical formula, if we have an example where we have a compound and we told that we've got the elements carbon and hydrogen, and we're given the percentages of carbon and hydrogen in that compound, and we need to deduce the empirical formula. Remember, the empirical formula is the simplest formula that we can make, and then the molecular formula is what the compound actually is. So to find the empirical and the simplest, whenever we have percentages, those percentages will always add up to 100%. So what we're going to do is first we write down our atoms. So we're dealing with carbon and we're dealing with hydrogen. And then we say in 100 grams. Because if we have 100%, we can say that those percentages are exactly the same in grams in a total of 100 grams. So in 100 grams, 85.7% is the same as saying 85.7 grams and 14.3 grams, because that adds up to then 100. So this is now the mass in grams. So now I have a mass and I have a periodic table which will give me a molecular mass for each of those. So I can take this mass and I can divide it by the mass I find on the periodic table. So for carbon, if I look at my periodic table, carbon is 12 and hydrogen is 1. So I can say carbon, I divide that by 12, and hydrogen, I divide it by 1. So this is now the MR. And we know that M over MR means I'm going to get number of moles. So the number of moles, when I type this into my calculator, I end up with 7.142 and 14.3. So now this is the moles. And I can get the simplest mole ratio by dividing each one by the smallest number. So the smallest number here is 7.142. So I divide that by itself. And I divide this by 7.142. So I end up with 1. And then when I divide that in the calculator, I get 2. So I have a ratio of 1 to 2. So that means there is 1 carbon and there is 2 hydrogens. So my empirical formula is CH2 to get the ratio. If I look at another example, so I've got a carboxylic acid, okay, W, which has a composition of carbon as 5.8, hydrogen as 4.5, and oxygen as 59.7. And they want me to show by calculation that the empirical formula is C4H6O5. So I'm going to do exactly what I've been doing before. So I say I've got carbon, I've got hydrogen, and I've got oxygen. I've got percentages. So in 100 grams, it means I have got 35.8 grams, I've got 4.5 grams, and I've got 59.7 grams. So remember, that is the same as saying mass. And I'm going to divide that by what I find on my periodic table. So again, I've got carbon, which is 12, hydrogen, which is 1, and now I have oxygen, which is 16. So I divide that by 12, by 1, and by 16. And remember, that is the same as the MR, which means I've worked out N as 2.98, 4.5, and 3.73. So none of these are whole numbers, or not even close to whole numbers. So what we need to do is always find wherever we can get a whole number. So if I was going to follow my normal standard, I would say 2.98 divided by 2.98, to give me one because that's the smallest number. But then 4.5 divided by 2.98 does not give me a whole number. I get 1.5, so it's not even close to a whole number. And if I do the same for 3.73 divided by 2.98, I get even less close to a whole number. So sometimes if I don't get whole numbers by dividing, sometimes what I need to do is I need to multiply instead. So the easiest thing to do is to go through and try our different numbers to see where we can get a whole number. So I would say my 2.98, for example, times 1.1. If I start with 1.1, I'll see what I get. And I get 3.27, so it's still not close to a whole number. But if I change that and I say 2, I get 3.57, so I'm getting closer to a whole number. 0.13, and I get 3.87. And then I try 0.4, and now I get over. So I'm going to try a number between 1.3 and 1.4, so I try 1.35. And now I get 4.0, which is the important part there, and the 2, 3 can be rounded down. So I get a 4.0. So that's how I now can say each of these values, if I times it by 1.35. So here I will end up with 4.0. And now I want to try that with the next number. So I say 4.5 times 1.35, and I end up with 6.0. So that's exactly what I want. So this one will give me 6.0. And then I do the same thing with the last answer, and I get 5.0. So now I've got the closest to my whole numbers that I would get. So my ratio is actually 4 to 6 to 5 because I need to multiply. So that means I end up with C4, H6, O5, which is what they told us in the beginning. And if I look at the second part of that question, I am given the MR is actually 134, and I need to use that value to determine the molecular formula of W. So the first thing I need to do is I need to take my empirical formula and find the molecular mass. So my empirical formula is C4H6O5. So I find my periodic table. Okay, and I know that carbon is 12, and I've got hydrogen as 1, and I've got oxygen as 16. So I say 4 carbons, C4H6O5, it's going to be 4 times 12 plus 6 times 1 plus 5 times 16. And I will get a molecular mass. So when you type that into your calculator, you should get an answer of 134, which means that the molecular mass is the same as the empirical mass. So that means that our empirical formula is our molecular formula. So our molecular formula is exactly the same as C4H6O5 because those are the same as each other. Okay.